In the spring of 2016, 8 students from the University of North Dakota embarked on a week-long storm chasing class. The class was taught by atmospheric science professor Matt Gilmore, and the van was driven by TAs Ron Stenz and Aaron Scott. Through the first 6 days of the class, storms were seen as far south as Big Bend, Texas, and as far north as Pierre, South Dakota. On the 7th and last day, the class started in Wall, South Dakota. The last day of the class was June 3rd, and the Storm Prediction Center in Norman, Oklahoma issued a slight risk for a large portion of Iowa, southern Minnesota, and portions of eastern South Dakota and Nebraska, and a very small portion of western Wisconsin. Despite the only 2% tornado risk issued by the SPC, our forecast showed that we could see supercell development, especially towards the beginning of the storm's life cycle. This is 250 millibars with a very prominent jet streak over South Dakota, with max wind speeds in that jet streak of around 110 knots, and a left exit region seen in southeastern South Dakota. At 500 millibars, wind speeds of 40 knots are seen over southern South Dakota and a small portion of southwestern Minnesota as well. At 850 millibars, you can see a very prominent low-level jet over southern Minnesota and Iowa from the southwest, and that low-level jet helped bring in some very moist temperatures, some very high dew points to the area that day behind a remnant squall line that went through South Dakota through the night. Mixed layer CAPE values of over 1,000 joules per kilogram will help feed the storms as they continue to develop and move south throughout the day. Dew points of over 60 in southeastern South Dakota shows that the low-level jet over Minnesota and Iowa is indeed bringing very moist temperatures to the area. Another thing we were monitoring throughout the day was the winds throughout South Dakota. The surface station at Aberdeen shows backed winds out of the south-southeast at this time, which is good for supercell development. However, the rest of South Dakota shows winds out of the northwest. And as the day progressed, the winds were forecast to become more back out of the southeast. The following images are from the 17Z run of the HRRR on June 3rd, and at 18Z or 1 o'clock p.m. Central Daylight Time. The model has storms firing in South Dakota and intensifying as they move into southern Minnesota and slowly diminishing as they reach the Minnesota-Iowa border. Looking at the radar at 1 p.m. in the area, you can see that remnant squall line storm system that went through all of South Dakota through the night is just to the south of Sioux Falls, and just behind that line is where the conditions for the strong and severe storms, are setting up what would eventually go on to be the storms we would be chasing. Development of those storms started at this time just to the northwest of Aberdeen. A couple of storms did go severe near Aberdeen, but the UND chase team was sitting and waiting for him in Brookings, South Dakota. A view of those storm tops could be seen very well from our location as well. At 3 o'clock Central Time, those storms had started to come together and create a squall line bow echo feature, but there was one storm just north of Huron that had formed in front of the line and was staying isolated, and still seen on radar at 4 o'clock. As that storm approached Brookings, the UND chase team again got a very good look at it. It didn't take too long till that storm started to catch up with us, and we needed to get back into the van and go, but not without keeping an eye on the storm as we were driving away.
That video that we watched the other day.
Oh, I thought you were being serious. I was like, what?
Where? HV supercells are difficult to chase because you have a very narrow viewing window into where the mesocyclone is located. Actually, this storm is weakening here, and this storm is starting to strengthen. Currently is just south of where we are. Best LCL heights are just east of where we are. LCL heights of about 500, which is very decent. 500 meters.
At 5:15 Central Time, the radar shows that the storms had clustered together very well, and at this point, the storms had gusted out. A very prominent gust front was visible on higher definition radar. The gust front can be seen very well on the radar on the video as a fine line in front of the storm, and at this point we were behind the gust front on 30 going towards Pipestone.
Alright, see that land spout?
Land spout.
Land spout.
Yeah. Directly northeast.
There's nice cyclonics, cloud-based rotation.
There's some pretty good rotation.
Right there,
Right
right in front of
there.
us.
Right here,
Large,
land spout
large
on the right.
land spout.
Watch my right.
Like right
The big one is
there.
right there. Right in front
Oh,
of us.
yeah.
Right in front of us.
Going south on 75 to try to get ahead of the line of storms, we see strong winds pick up a lot of dirt on the ground and also some spin-ups out of our windows.
Coming off the ground.
Looks like there might be a little funnel fingering down.
Going further south on 75 into Iowa to try to get ahead of the gust front and shelf cloud, and we stop in northeastern Iowa to get a view of the storm as it approaches us.
Holy crap.
The day before these storms, a forecast sounding showed better potential for supercells and tornadoes, as this forecast sounding shows more backed winds at the surface and more area under the curve on the photograph from 0 to 1 kilometer. While morning soundings from Chanhassen and Aberdeen did show more backed winds at the surface, those backed winds became veered as time went on, as showed by the 7 o'clock Chanhassen sounding. This sounding from 7 o'clock also shows weak vertical shear, which meant storms could become high precipitation easier and gust out, which is indeed what we saw. And while LCL heights did get as low as 500 meters in southwestern Minnesota and southeastern South Dakota, mixed layer CAPE values diminished greatly as the sun started to set and the storm started to move into Iowa. Also, the best shear values were seen in northeastern Iowa, but again, as those storms started to move into Iowa, they began to die off rapidly. An exact count of tornadoes from that day is unsure, but from this video, at least 4 landspout tornadoes can be confirmed, with several other videos recorded by myself showing dirt spin-ups on the ground that could either be gustnadoes or possibly landspouts as well. The first landspout tornado was reported by the UND Chase team on their official Twitter page, shown by the image on screen, which was reported to the National Weather Service in Sioux Falls. That report can also be seen on the SPC webpage, which is shown here.